Okay. Hello, everybody. I'm Raul Furnica. I'm the YouTube tech lead of the API team. And I'm going to present our new version tonight that we just launched a couple of weeks ago, I think, not even months. And I'm going to walk you through everything we introduced in the new version, what's the design that's behind the new version. And I've been actually on the API team for 6 years now, so that's like my whole life, APIs. So I'm going to talk about my experience and everything else that you asked me about related to APIs. In particular, I work in Zurich, in Switzerland. Okay, I'll try. In particular, I work in Switzerland. I'm from Europe, so I just arrived like 2 days ago, so I'm really jet lagged right now. But bear with me, and if I fall asleep, like wake me up. But hopefully that wouldn't be the case, and would be.
We can also turn it up a little bit.
Okay, is it better?
Yeah.
Okay, sounds good. Wow, I can hear the echo. So I give an overview of the introduction I give it to the APIs, basically talking about the terminology of V3, which is a bit different than V2, and that's a good time for me to ask you, have you ever used the YouTube API before? Okay, so we have some people using it, and did you use V2? Okay, has anybody tried V3 yet? Cool, wow, that's good. And then I'm going to talk about how we design it, design principles, and in the end I'm going to talk about new features that we don't have in V2 and we have in V3. We introduced in V3. And before that, I just want to basically let you know, in case you didn't know. So that's basically me when we launched V3. You can scan the code, or you can use the URL there. By using that, you use the API V3. I'm going to try to open it.
So will you be sharing these slides afterwards?
Yes.
Okay.
Yeah. And this is okay, the screen size is really small, so it's kind of weird, but this is a live API query that we can make right now from this URL, so you just click on execute, and then I can explain what happens, but most of the talk is just explaining all that's behind this. So we've done a request to retrieve video metadata that maybe you can figure from the URL, and then we have a web interface where you can try any API call directly without actually writing the tool or using a client library yet. So you just like test it on this web interface. You have links to this interface later on, actually on the last slide on the resources. And it's a really cool interface that allows you to specify the parameters, but if a parameter is like a enum parameter, you can actually choose from the values allowed and so on. So it's a way to discover the API and get into YouTube APIs, and YouTube in particular. On the response, you just get metadata about video. So it kind of looks like this. This is the first view I'm giving you, but I'm going to go back to it and show a bit more. So in the first part of the talk, I'm going to walk you through the API structure and terminology. And the way I'm going to do that is that I'm going to slowly start taking the base URL and complete it until we get to a full request that we can fire against the API, and I'm going to explain every single path and term that we have on the way. So first thing to notice is that the YouTube API is now hosted at googleapis.com. It only works on HTTPS, and very first part of the path is YouTube. At googleapis.com, you can find any API that Google creates. So you can find like G+ APIs, you can find contacts, contacts works too, but Gmail, calendar, all APIs are under their own name. And then the very first thing you'll see that is particular to YouTube is the version of the API. The version of the API is, as you might know, a version in an API is just naming of a particular schema of the API. Minor versions are usually backwards compatible and they add to the API schema. Major versions are backwards incompatible and they change the schema in a non-reusable way from an app perspective. The naming in particular is v major.minor. It's normal, so what you would expect. And it's part of the URL, so that makes it really clear which version you're using to contact the YouTube API. YouTube APIs are all RESTful, and does everybody understand what RESTful as an API means?
Yes.
Cool, awesome. So in that sense, we have data models, and we have a layer of business logic. So I'm going to talk about both, and I'm going to describe them. What do they mean in the YouTube API? And first thing in the terminology that I want to introduce is collections. Collections is, you can take it as the sum of all resources that are of the same type. So collections would be anything that on the product side we would call nouns. So anything that YouTube defines as, or the users of YouTube define as a noun, like a playlist or a video, it's in the end forms a collection. So that's the next part of the URL. It identifies which collection you want to work on. I've listed here all the collections we support right now in the API. We're going to add on them, and we're going to get to the point, like in V3 right now we have less than we have in V2, but we're going to get it to the point that we have everything that we have in V2, and then we're going to add some more. The main parts are, as I already mentioned, videos, playlists, and channels. That's the main defining nouns of the YouTube product. On top of that, there is activities, search, and subscription. Those are a bit more special. Activities are more about the social side of YouTube, so you follow other people's activity, you subscribe to other people's activity, you see what they're doing on YouTube, you get to discover new content via them. In a sort of weird way, even recommendation is an activity, so when YouTube thinks you should be watching this video, that comes out as an activity, as a recommendation. YouTube tells you, or thinks this is good for you. Search is another collection, but I'm going to detail that a bit later because we actually reworked search in V3. And subscriptions is just videos you can get to and subscribe the channels you have subscribed to. By introducing collections, I already talked about resources a bit. So resources is very hard to define. I mean, it's pretty clear what it is, but if I were to define it, I would say it's just like an identifiable unit of data in an API. Identifiable is the important part, so every resource has a resource ID. The resource ID is unique and can point to that particular resource only. The resource IDs are, however, not unique amongst different collections. So a video ID may collide with a playlist ID. We don't necessarily care about keeping resource IDs unique on the entire web, which is something that we used to do in V2, but we just found out that that was very hard to use, and people got confused because they always had to take a YouTube ID that you would know from a website URL and prepend something to make it look like an API resource. So in V3, we're reusing the same resource IDs as the website does. So if you take a video ID from a website URL, you can just take it into the API and use the same thing. That, as I said, may cause collisions on different resources, but you just need to be aware that this is a video that I'm talking about versus a playlist. And the chance is pretty low as well. Again, they're the same as the YouTube nouns, so it's a video, playlist, and a channel. And the resource ID, like right here, you can see the collection is videos. And then after, we're already moving into the parameters that we're sending on this API call. And that's ID equals and then the value. And then there is some extra to the request, and I'm going to explain a bit later. But if you take this request as it is and you fire it against an API server, you would get a response. So that's already a fully built request. So we got so far, it was pretty simple: version, collection, resource ID. How does a video resource look like? So YouTube is about videos. I don't know if I should mention that. But since videos are the main resource of YouTube, so oops. That is true to the API as well. Video resource is the most complicated resource we have in the YouTube API as well, in terms of schema and the number of things you can retrieve from it. And I just took here the main important fields of a YouTube resource. And it's exactly what you would expect. It's the time the video was uploaded to YouTube. It's the channel the video is uploaded into. It's the title, the description, the thumbnails, and a category ID and tags. This allows you to render the visual snippet of a video and even like start playback in an embedded player. I didn't include that here, but that's there as well. There's a lot of information extra that you can request with specific requests. Sure.
What's the key property of
Key property. So that's a very good question. So in V2, if you notice, okay, sorry, to repeat the question, thumbnails has a key, and the question is what is the key for and what does it mean? Thumbnails is basically a map in JSON terms. And the reason it is a map is that we found out in version 2, where it was a list, people started depending on the order of the thumbnails we returned, particular order. So people would expect that thumbnail 2 is of size 144 by 100 pixels. And when we needed to introduce new thumbnails, we always had the issue that we can't insert it in the first or second place because that matters. But even at the last place, it can break other people because they make assumptions about a number of thumbnails available. So to solve all this, we turned it into a map, and the key is actually the name of the thumbnail. So it's going to be named default. If you don't care, you use the default one. If you want the HD thumbnail, you're going to use the name HQ thumbnail and so on. And that means it's not particularly ordered. It's just you identify by name what's the thumbnail you want to use. There is another thing that I highlighted here, and that's the kind. Kind is a field that every single resource in YouTube API has, and it defines the type of that resource if you want. So they're all going to be YouTube hash and then the name of the resource, so video in this case. This is there because in any JSON response, looking at just the resource, you cannot tell what type it is. So if you want to know for some reason, then that basically gives you that information. And if you're wondering, this is the schema that the API is defining completely. And it's based on JSON schema, if you know it. And you can retrieve this information at runtime from our servers at any time you want. So the schema is public and discoverable. Now we're getting into something that is specific to the YouTube API, and it's new for version 3, and that's parts. So we discovered that our resources are very bulky, and in order to retrieve a particular resource, you might get 100 kilobytes response even for a video in version 2, for instance, which is really a lot for bandwidth consumption. So people need better control in what they're retrieving about that resource, and also need a more modular response and modular resources in particular. However, a video is still a video, and it means many things at YouTube. So if you're asking an uploader what a video means, it might be just the bytes he uploaded, and then the title, description, and a bit of upload metadata. But if you're asking an advertiser, and advertisers are users too, then you're basically finding out that they have very different needs related to a video. They don't care that much about the title maybe, but they care a lot more about the stats. How many times was this video watched? How many times was this video embedded on a particular site, or which sites was embedded on, and so on, right? So analytics in that sense is much more important there. So in order to not have different APIs for all this, but and still call that resource a video, we came up with parts. Parts are a grouping of fields that make sense to be both managed and retrieved at the same time. And every single resource you make against the YouTube API version 3 requires that you specify the parts you want to fetch on that resource. If it's a write operation, then it basically means that you're just updating that part alone, and every single part can be read or written on by itself, independently, or you can do that on multiple parts at the same time. There is no way to say, give me all the parts today, which is good for us because it allows us to add new parts without changing backwards compatibility, or without having to like break apps already there. Because if apps would start depending on certain parts being there or not being there, that would be a backwards incompatible change. So this is good for us, this is good for our clients, and it really gives a lot of control over the bandwidth for every client app, and the bandwidth is really important, particularly in YouTube. So I'm going to give a lot of examples later on, but to start with, let's look at two particular parts video defines. One is statistics, one I talked about a bit in the analytics use case, and another one is the status. So statistics, for instance, is much more interesting for people that are looking into how is this video doing, how is it shared, how many people like it or dislike it or comment on it. And the second status part is much more about controlling how privacy of the video, and it's much more important for an uploader perspective, for instance, or it's much more important from a playback perspective. If the video is private, you can't really playback. You can't really do a playback for that video, right? So you can't see it. So the two are relatively different, but you do get the choice to say, I want both of them, or I want one of them, or I want none of them, basically. There are two parts that are generic enough that show up on every single resource. One of them is the ID part. It doesn't make sense to return a resource without returning its ID. So there is no need to call out the ID part in the part parameter. You can just like assume it's always going to be returned. And the second one is a snippet, which kind of goes with the philosophy that if it's a YouTube resource, it should have a visual representation or a thumbnail. It's kind of something we're trying to introduce in every single operation that the YouTube API supports. We didn't have that in version 2, and people had a lot of problems trying to retrieve thumbnails that are about to resource, but not necessarily the resource not necessarily having a thumbnail directly. Like, for instance, subscription. It's a channel you subscribe to, but in order to get a thumbnail for that in version 2, you have to actually take the channel ID from the subscription and then fire another request against the channel's feed, and then you get the thumbnail. In this case, we're just saying we want to make it easy for people to visualize any YouTube resource and put it on a web page. So that's all the parts you need, all the fields you need to build a small snippet. If you need a lot more, then you have other options to get more data. But we're kind of inlining a bit of data to help you out there. Now we're moving to the business logic there. So basically on the operation side. So then I've been talking about the resources in particular, so collections, resources, and or data model. collection as resources, IDs, and parts. And now let's see what kind of calls we can make against the API. So in terms of business logic, we can have we can define the concepts as services. Services are pretty much linked to collections. So every single service operates on a single collection and only one collection. And it allows management of that collection. So you can do both reads and writes on that particular collection. In that sense, they're all linked to the collection's name. So there's a channel service, there is a video service, there's a player service, and a playlist service, and a search service, and so on. Services in particular handle all the logic around authentication, around privacy, ACLs for accessing the data, and so on. For authentication, we use OAuth 2 in version 3, and only OAuth 2. And if I'm to describe the service methods, this is just by the book. It's not particular to the YouTube API. Any RESTful API would do the same. We only support list, insert, update, and delete. First one is a read. The last one is a write. And the syntax is dictated by HTTP in a RESTful API. So in order to do a list, you have to do an HTTP GET call. In order to do an insert, you have to do an HTTP POST call, HTTP PUT for update, and HTTP delete for deleting and resource. So in RESTful APIs, the verb of the HTTP request gives you the method that is going to be invoked on the server side. The URL is going to give you the rest of the signature of the method that is being invoked, that is being called. In the case of inserts and updates, so post and put, there has to be a request body that contains the request, the resource that is being affected by the write. So in the case of insert, it's going to contain the resource that is being created, or the metadata about the video that is being uploaded, for instance. In the case of update, it's the resource that is being altered, so the new title that you want to set on a video, for instance.
So how come there's no ID in the update?
Good question. So we noticed in version 2 that there is duplication between the specification in URL and the specification or the data coming in the request body. So in version 2, we had this issue where in insert, the ID was in the request method as well, so in the URL and in the body. And what do we do when they conflict? Like when you're telling us in the body that you want to update video ID X, but in the request parameter, you say Y. So in that case, we have to reject the request. So we just want to make it simple and reduce that duplication. So the post actually has always been clear because you don't have the ID prior to creating, but the edit is really where the question is. The put will contain the resource ID in the resource you're editing. And actually that, in the body. And that allows us to even go further and edit multiple resources in the same time. The delete, however, because it's a simple call, and it doesn't require us to send a body, and we actually, as much as we can, we want to leave that out. So it's hard to put a body in a request, and we know that. So for the delete, we're taking the ID in the URL. And another particular thing that YouTube API did that is not necessarily specific to all RESTful APIs, yeah?
Do you maintain symmetry between gets and deletes? Like whatever is get when using a symmetry parameter, gets and deletes the exact same.
The question is there is symmetry between the 5 types of methods? And
no, the symmetry between, so again, the URI looks very similar to what the delete URI looks like.
so the get URI looks very similar to what
The parameter,
the
right? So I could be trying to get my ID or my author.
yeah.
Or I could be trying to delete my ID or my author.
Ah, I see what you mean. So we don't support the exact same parameters on list and delete, but we try to for as much as we can. So, but bulk deletes, which would be if you delete something by author, you would delete everything. It's something like we're looking into. We don't have it yet right now, but it's a big question if we want it, because it's super powerful, but in the same time it's super damaging if you do it by mistake. So it's a balance there that we haven't yet drew the line where we want to support it. Okay, so filters. Filters is a new concept in the YouTube API. They apply to lists in particular, and what we're trying to say is that every single list, if it's unfiltered, it's supposed to return the entire index YouTube has. So if you're doing a list of videos, supposedly we're like being asked to return the entire index of all videos ever YouTube had in one request, right, in one response, which is not feasible. So in order to cope with that and to basically give people a clear notion of what they can do to filter, to narrow down the number of results, a particular API method with effect, we added a particular concept called filter. So every single YouTube API list request has to specify at least one filter, and actually at most one filter too. So you cannot combine filters. But there can be extra parameters that define how the filter works. A couple of filters that I want to talk about is the ID. One of them, the most important one, is the ID filter. And we took it a bit further than just allowing you to retrieve a single resource by ID. We allow you to retrieve any number of resources you want by ID. Well, not any number. We actually have a high limit of 50 that we support. But it's a comma-separated list of IDs that you can put in the ID parameter. And that matches from the entire collection only those resources that have that ID, for instance. Another filter that maybe is a lot more interesting to see on the playlist items. Playlist items is the collection of all entries in a playlist, if you want. So not all playlists. So there are playlists, and there are entries inside a playlist, right? Videos inside a playlist. So that's playlist items. If that makes sense? Kind of? Okay. So those you can filter by a particular playlist ID. So the call there is exactly, give me all the videos in this playlist. And that's the filter playlist ID. And for search, of course, you have a filter by textual keywords that you want to match when you return, right? And there is a particular one, the mine filter, that just returns data that belongs to the currently authenticated user. So whatever you uploaded, whatever you created as a playlist or in a playlist. And on the like changing the behavior of a particular filter, I have here an example where like you search for a particular term, like APIs, and you want to change the order in which the results are returned. So then there is an extra parameter, which is not a filter, but it's just a normal parameter that affects how the response actually looks like, and that's the order equals rating. So you want to sort them by rating.
Yeah. Page number.
How about?
Page number.
Page number?
If I only want the second.
I'm going to talk about that in 2 slides. Yeah, I think 2 slides, if I remember right. So all services in YouTube API define 2 particular filters. The ID filter, which allows you to return 1 or more resources by ID, and the mine filter. The mine filter is an interesting one because it actually requires you to fire an authenticated request. So if you're trying to use the mine filter but you're not authenticated as a user, then it doesn't really make sense, right? So you don't really have anything as a public API call. And also it allows you to build an app that manages the user's account if you want, or just adding those features to an app that already exists. And let's talk about paging, as I said in 2 slides. So paging is the other option you have to reduce the number of resources that will be returned on a particular request. And in V3, we have changed paging, and this is a big change versus V2. In V2, the paging was indexed, so you would always say start index 25, num results 5. You have a question, or? Okay. So that meant for us that we have to return from the 25th resource that matched 5 resources. In V3, we're using token-based paging. The reason for that is that we get more flexibility to both give you consistent paging, so if the collection changed since you first requested the previous page, you would actually either see duplicates, like resources that you saw on the previous page with index paging, because you can actually tell when you actually did that request, while tokens allow us to do a much better job at that. That doesn't mean we're doing it on all requests yet, but that's where we want to be. And the way it works is that on every response, you have a page info. So it tells you what are the total number of resources that match your filter, and it tells you how many results per page we are returning, which is always identical to the parameter you sent over that says match results equals 10 or whatever. The default is 5 right now in the YouTube API. And we also give you the next page token and the previous page token, so for navigating back and forth. That's the token you would use in the page token query parameter, and that would tell us to retrieve this particular page now. So in that sense, the API interface simplified a lot, if you want. It's not as powerful as index paging in the sense that it doesn't allow you to skip pages and go to the particular page you want directly. This only allows you to go page by page.
So the page token, I need to get that from your response.
Yeah. So you can't just skip 10 pages. Yeah. Yeah, that's the difference between the index paging and the token paging.
Are you going to do less skipping in the future?
If there is a big use case and a big, if it's a big feature request to have that, we will look into it. But right now, it's like we're just happy with it so far.
Well,
okay.
You got to repeat questions.
Okay, so the question is, if I got it right, are we going to add a way to skip pages? And the answer so far is that we don't have that. But if it turns to be a very important use case to support, then we will add it. But basically, we need your feedback.
Just use numbers.
That would be back to index paging, which is the one we actually think it's inferior in design to this one right now. But because of the problems I mentioned, so you get duplication. Because the collection changes in the time you're browsing it, and we can do much better with this because the token actually captures part of the time. Yeah. So we can give you consistent browsing with token.
So, if the underlying data changes, what's the expected behavior? Would I not see the new data at all?
Yeah, with token, so the question is if the data behind changes while you're browsing a collection, what's the intended behavior? So the intended behavior is really that you're not affected by that, and your view of the collection stays consistent even though the data behind it changes.
Are there special values for the tokens when you're at the begin and end of the list?
Are the special values for the token when the list, at the beginning of the list or at the end of the list? Beginning of the list is marked by not sending a token, so that's 0. Or end of the list, it's not something we're super strong on because the more you browse, the less we think it's relevant. Like in search, for instance, it's not relevant to go to the millionth response. But to tell if it's a finite collection like the items in a playlist, then you know you reach the end because you're not going to have a next page token. And you also know by the total results how many there are in that playlist. So you do have a number directly from the very first request.
What happens if video is deleted? Because you snap for the condition.
If a video is deleted, you're gonna see some metadata about that video, but of course it's not. You cannot play back the video anymore. So it's like with any web reference. If you want, you still have the link on a page about another page that was deleted, but once you try to access it, you can't get anything. So it's the same thing. You get the reference to the video, you still get the ID, you might still get some metadata, but you will not be able to view the video.
There wouldn't be any metadata in that, say, when it's been deleted?
There is some metadata that is being referenced. So for instance, that's true for the YouTube website too. So if you have a video in your playlist that you don't own, somebody else owns, and that particular person deletes it, you still see some metadata about that video. And that's the reason for that is because we need to allow people to manage their playlist. So they need to see that that video is not available anymore and then delete the playlist item and create something or replace it with something else. And also we don't want to get into the behavior that we like to randomly remove stuff from people's playlist and then they don't know what's happening. Okay. I've already talked a bit about the response format. Mainly the default format is JSON. I guess almost everybody is familiar with JSON right now, which is one of the big reasons why we incremented the major version of the YouTube API to switch Atom XML to JSON and more modern standards. And response formats, it's lightweight, it's easy, it's a textual format, it's easy to debug, everybody understands it, it's human readable, it's machine readable. It's a lot more compact than XML and Atom, and it is the default format, as I said, but we're actually thinking that if people care about bandwidth, we can do even better than that, so we're working on external protocol buffers. Which means we're allowing people to get binary serialization formats, which are much more effective in terms of bandwidth, even than JSON. And it is the most efficient version, but it's also a power user feature. So you don't really, not everybody's going to use it, I'm pretty sure. But if bandwidth is really important, then people are going to use it, I think.
Just curious, are you still going to support XML?
No, we're not. The question was, are we still going to support XML? The answer is no. With the new version comes a refreshed set of client libraries, which are actually really awesome, and you can try them on. I have the link as well on the last slide, and I'm going to leave the last slide up for a while. I'm going to send the slides around as well. But we do support a lot of languages now compared to V2. The advantage is that since we're building on the same technology stack as every other Google API, we get the client library support almost for free. That's good for us, that's good for you as well. So we're having .NET, Dart, Go, even a Google Web Toolkit extension, Java, JavaScript, Objective-C, PHP, Python, and Ruby at this point. It's probably anything that comes along and people are gonna use, we're gonna add to this list. So this slide, I don't know if I didn't introduce Jarek before, or maybe everybody knows Jarek. So he's our awesome dev advocate, and he was kind of complaining when I was building the slides that they're kind of dry and we need some personal information about you and all that. So I'm already told you I'm from Switzerland and all that. So this is about me, like we need a break from all the technical stuff, so let's check it out. So that's it. So that was my first snowboard jump ever, like last year, and the last one I did. But basically, the fun thing I want to say is that I like my extreme programming. as I like my extreme sports, which means cowardly safe, which is good for you, I think, because I'm not breaking the API every month or every week. But it's kind of like my philosophy in a sense, or what I've come to learn in a very painful way, I might say, with every single app that we broke or like we took back. It's like work on the API team can be very back and forth. So you want to evolve the API and you want to do cool stuff, but then you launch it and stuff breaks and then you have to take it back and you have to figure a way to put it out there in a way that people can use the new cool stuff but doesn't break the apps already existing. And fortunately, for everybody actually, YouTube API is used by our internal apps as well, a lot. And the Android app that we're having on the Android phone, for instance, it's using the YouTube API. So in that sense, it's the same API we're using that you're using. And that's good for everybody because first, it catches issues very fast for us. And second, we can really like, if you feel like it's easier for us to ignore like third-party developers, it's really hard to ignore like first-party developers that come at your desk and it's like, you broke my app, so you have to fix it. And that's where the cowardly safe comes from. Because we did that a couple of times, and then it's like, oh, okay, we need to stop doing this, and I need to stop waking up at 3 a.m. for like people pushes that broke apps, and we need to do better. So, and I think we actually have a very good track. Like V2 has been around for 5 years, V1 has been around for 6 years, and is still working. So, I think we're kind of there. We're doing it. So. So in the next part, which is the second part of my talk, I'm going to talk about design principles and how we've built and what was our thinking behind building V3. It may not be super interesting from a client perspective, but it may give you more light on like how APIs are being built and what do we consider when we think about it. This slide in particular, it's not anything that I came up with. I just went to Wikipedia. Kind of, and I took everything, the generic principles from there. So the YouTube API is a service-oriented architecture, and any RESTful API is that. So you have services, as I talked about, and you have resources that those services work on. That means that in itself comes with a couple of principles that are listed here. So you have a particular contract for each service. People have to know what that service does in order to be able to use it. You have loose coupling. So the two different services shouldn't do the same thing. The more things you have that are similar or do kind of like the same thing, the more confusing it is in an API. So you want to keep that to a minimum. The service is an abstraction, so it doesn't tell you about the backends or like the logic that's behind it. It just tells you this is what I do, and you don't need to understand what's behind it. And that makes it easy to use the API. The service is also reusable, so instead of coming up with new things all the time, you should find out ways to reuse the existing services. So we always have the choice of adding new services. But the first question has to be, do we have already a service that does this? Services are autonomous, so they work independent of charter. They're stateless. That's kind of like almost all web services. They have a schema that can be read at runtime, so there is discoverability. And they're composable in the sense that one service can work with the other and so on. And in particular for RESTful, we care about scalability and interfaces. But to go a bit into depth with this concept, so what have we done in particular for the YouTube API v3 in related to those principles? So the contract of the service and the discoverability, it's done via the discovery service that all Google has. So any single Google API right now that is served on googleapis.com you can go to the discovery service, that is that link over there, developers.google.com/discovery, and then you can download the schema of that service and find out what are all the parameters that every method takes, what are all the methods that can invoke, and so on. Our own client libraries are using this document to build their model, their data model, and also it's something you can analyze to do any API reflection that you might need. Or if you're building tools like IDE extensions for particular products or APIs, then you can integrate with that. It also contains documentation and so on about particular features. This is a big new thing. We didn't have anything like this in V2.
Question.
Yes.
So if you have discovery, are you going to have something like a interface definition language, like in XML? So please, word services, there is words still to describe what the service is.
So we're using the JSON schema for that. The question is, if we have discovery, are we going to have like an IDL or like an XML description language that the discovery document is written in? And the answer is that basically we use JSON schema. We check out at jsonschema.org, I think. And I just pulled it up here so you can see how the document looks like. And it's JSON, pure JSON, that tells you the name of the API you can see right now, what's the revision, what was the description, what are the icons for the API. And then if we go on into the actual definition, you're going to get authentication information. What are the authentication scopes the YouTube API supports? And then we get to the schemas, which tells us every single resource, what's the name of the resource. So we have an activity resource, and then what are the fields on that resource. So we have an ID, type, a description, and so on. Every single field is described with documentation there. So the description you see there is basically the documentation of that field. And you can read it in plain here, or you can add it to a client library, or you can use it to generate a documentation document or anything like that. And later on down the document, you're going to find the rest of the all the methods and everything else about how the API can be used and what are the parameters for each method and so on.
So is this going to be a standard JSON schema, or is it Google specific?
It's a standard JSON schema. We don't do anything specific here. The question was if this is a standard, a web standard, or we're just using some Google specific tools. On the reusability part, a good example that I can show you right now is the use of playlists. So there are many ways or many lists of videos that you can define on a particular account. The first request that I'm showing here, it's fetching my channel. So as I'm authenticating as a particular user, I'm fetching my channel and I'm asking for the content of that channel. And in the content of that channel, there is a field called related playlists. If you look at the field, it's a map, and the names are likes, favorites, uploads, watch history, and watch later. They're all features of YouTube, but they're not particularly playlists in that sense. However, they're all playlist IDs, and they all can be fetched via the playlist collection or service. So in the playlist service, I can take into the ID filter all those different IDs, put them in, and I'm going to get the playlist and all the content of the watch history and watch later and so on. So in that sense, if you have written on the client app a playlist player, let's say, you do not need to deal with different APIs for the watch history or the watch later. You can just feed the same data to that player, to that playlist player, and it's going to be able to do playback through that. So any video list is, in that sense, a playlist. We could have went the way that we have different services and different collections for it, but reusability, it's a big principle that we care about in V3. Autonomy is the other big one, which has a good side of the coin and a bad side of the coin. It's no perfect answer to this one, unfortunately. And it's also different from V2. Like on V2, we approach this differently. So in V3, every single service operates on one collection only, and not more. So in V2, every single service could operate on the same resources as other services. So we had playlist service, which contained videos, and we had a video service or an upload service that contained videos as well. In V3, there is only one place where videos are being retrieved from, and that's the video service. The playlist service would never inline a video in itself. Like you would have metadata about the video, but it will not be a video in that sense, if you want. Or maybe it also ties into inheritance versus composition, kind of. So resource inlining is not supported. The way to make that better and not say that we cannot retrieve anything about the linked resource, for instance, in a playlist, you have playlist items there about a video, right? Is that, as I told earlier, we have a snippet for every single resource returning the API, where you can get information about that referenced resource. It's not a lot of information, and if you need extra information that only the video resource has, you need to fetch the video in the end, but it gives you a starting point. To give an example of this on search, which is not actually on the slides, but on search, you can find videos too. However, in search it's really important that we conserve the bandwidth and we actually, it's not so important that we have a full video description, for instance. So the search snippet, it has also a description field, but it's not going to inline the entire video description, but just a snippet of the video description, which makes sense, because in search you want to see snippets about the stuff you matched, right? So that's the difference if you want it. Search doesn't return videos, it returns search results, but those talk about videos. Another thing to notice is that the ID of a search result is actually a composed ID. So it has a kind, which is the same as the type of the API response. So the kind could be video or playlist. So you might have matched the video or playlist. And then it has the relevant field, the video ID or the channel ID or the playlist ID filled with information that you need. So it's really both autonomous, like search can function without the video feed or the videos collection, and there is composition there too. So search refers to a video. And that's the slide here, because I was saying that's the reverse of the coin, so that's the good part. The bad part is that we don't get the information about a video inlined in the search response. And in order to get that, we need to follow up with a second request. Now, I talked about the ID filter. The ID filter is what I would like to call the poor man's batch. So you can do a batch, literally. You can take a number of, like up to 50 video IDs and put them in the ID filter and return them all at once. So that means if you're writing an application that, say, uses playlist items, and you do a request like one of those two here that returns particular items in a place, and those are videos and you want to have more data fetched about those videos, you don't need to follow up, say you retrieve 25 playlist items, you don't need to follow up with 25 requests, but you follow up with a single request where you put all 25 videos you want to return. So it's composed and it's different. There are autonomous services, but we give you tools to make that easy, so you don't have to like query too much and batch as much as you can. And that would be about design principles in V3 and how we apply them. How do we apply them to V3? Next, I'm going to talk about migration guide and deprecation of V2. Is there any particular question about design principles in particular?
It's pretty good.
Thank you. Okay, let's talk about V2. I didn't want to talk much about V2. It's like V2 is the past, V3 is the future. You know, it's like we're much more excited about V3, but that doesn't mean that, I mean, as I said, we have a long track of like stability in the YouTube API, and we don't want to like ruin any of that. So don't worry about V2 going away too soon. It's going to go away, but not anytime soon. We'd be supported at least until April 2015. We will announce you when it's officially deprecated. We didn't deprecate V2 right now because we want to add a bit more features to V3 before we do that. And V3 is we're still working on it. And we're adding a lot of features to help you migrate existing apps from V2 to V3. Amongst those, we have user authentication. So if you're using OAuth 2 in V2, it's going to work in V3 too, kind of like the same way. The scopes of in V2 are accepted in V3 as well. The scopes in V3, however, are not backported in V2. So once you switch fully to V3, you're just going to go ahead from there and you don't need to fire back requests with V2, hopefully. Authenticated in that sense. The developer registry, sorry, yeah.
How do you handle the case where your developer key is not secured by JavaScript applications or open source projects?
The question is, how do we handle cases where the developer key can be read in plain from the code, like in JavaScript? There's not a good answer for it right now, so you can put the developer key in a header, but if it's JavaScript, you can always look at the code and see what happens. We can't, developer keys are sniffable in that sense. We can't really super secure them all the time for all cases.
Okay, is there a way to specify that I'm an anonymous developer or something like that?
That's another good question. So is there a way to specify that it's an anonymous developer? The version 3 doesn't allow unregistered traffic. So in version 3, every single call you make, you have to have a developer key for it. So in that sense, there is no way to do anonymous calls. Yeah. So yeah, there is no good answer for JavaScript in particular, for JavaScript client libraries or like clients. There is a way to hide it if you have a server application and then you do it on a server, not on the client side. But that can be harder to do than it is to say. So we're aware of it and we're kind of fine with it so far. If we find that it's a lot of abuse happening because of that, then we're gonna look into it. But yeah, it's a good question that I don't have a good answer to. And because we're talking about developer registration in particular, so if you register with V3 today, you're going to be able to use the same key, the same developer key in V3 in V2 as well. So the only thing you need to do, if you want to keep firing requests against both V2 and V3 for a while and have a migration in steps and not switch all the time, is start using V3 developer keys. And resource IDs are interchangeable between the two versions of the API as well. Any particular question about migration? Yeah. I can't really hear you. You mean video tags? Do you mean video tags? Yeah. It's a good question. So I think back here somewhere I was showing the video schema. Yeah, and you actually do have tags on the schema. But recently YouTube has removed video tags from read. So they're not publicly accessible. However, tags are still there and they're accessible to the uploader. That's a product decision on the YouTube side. On the API side, we don't have much to say about it, or we don't have like any particular reasoning, and I think a PM would be much better to answer that question, or maybe do you have more details?
Yeah, I think the answer is, so our answer is complex. So you're using tags in your applications to use a specific set of content. We have Complex API that allows you to use the free-based IDs and then look up the video based on video tags.
Yeah, so I'm going to talk about topics a bit later, and I'm going to introduce you to that. But basically, Yarik's answer was that topics are the new tags, kind of what I can say. Okay, so let's go into the new features that we had in V3 that we didn't have in previous versions. I'm going to highlight two in particular. There are more than that, but I'm not going to take like too much time. So universal search is one of them. So as I said, we reworked search. In version 2, you could search only on particular indexes, so you could only search videos or playlists or channels, but not a combination of those in the same time. In version 3, we're adding universal search, which basically allows you to search anything at the same time, or it still gives you the option to restrict the search to a particular resource type, like just videos, or just channels, or just playlists. I talked a bit about how that looks like as a search result, as a search resource, but the benefits of that is that we get to do the ranking and the relevance on the server side. So we might know, given different terms, like channel is the best fit for the first result versus a video, and so on. I'm not going to show it right now, but the way it works is that in the search response you get the snippet about the resource match, and then the ID of the resource if you want to fetch the full resource that was found. So the use case we normally think about is that you show a list of search results, and then it's the same thing that a user clicks on a particular search result and goes to the details of that resource. It's kind of like the same API operations supporting that. And I'm going to show you a video about topics, free-based topics that we're introducing into the YouTube API, which is another very big feature that we're adding.
Wouldn't it be amazing if Google could understand that the words that you use when you're doing a search, well, they aren't just words. They refer to real things in the world. That a building is a building, and an animal is an animal, and that they're not just random strings of characters. If we can understand that those words are talking about those real-world things, then we could do a better job of getting you just the content that you want off the web.
The way Google is trying to build information about real-world connections is by building a knowledge graph. The knowledge graph is about collecting information about objects in the real world. The object could be a person, could be a book, could be a movie, and many other types of things. For example, for a famous person, we collect relevant data about them, such as their date of birth or how tall they are. We can also connect that person to closely related objects in the knowledge graph.
Let's say you're interested in Renaissance painters, or how about how many women have won the Nobel Prize? By understanding the relationships between things, be it between painters in the Renaissance or women in the Nobel Prize, Google can do a better job of understanding what it is exactly you're searching for.
One of the first features we are going to introduce, which applies the knowledge graph, is a panel next to the web results.
When you have a question to answer, others may have come to Google already to search for the same thing. Google can jumpstart your research process by combining the information that others found useful with the information in the knowledge graph.
All of the collective human wisdom that comes through our search engine, what people are searching for, tells us what are the interesting things to put in our database.
Take Leonardo da Vinci. Let's say you wanted to learn about the most important Renaissance painters. You might search for Leonardo da Vinci because he's the only Renaissance painter you know about. Now, you'll see information right in the search results that helps you explore the broader topic of Renaissance painters. You'll see some of the most famous paintings from that era, like the Mona Lisa, and discover other painters of that time, like Michelangelo and Raphael.
We're in the early phases of moving from being an information engine to becoming a knowledge engine, and these enhancements are one step in that direction.
As we grow the knowledge graph and make it larger and richer, we're really excited at the opportunity we have to understand more of the user's queries, to understand more about the information that's out there on the web, and intelligently connect the two to each other.
So, this is about an effort that is Google-wide, and there is a lot of it going at YouTube. So YouTube is figuring out particular topics associated or particular free-based topics that have been talked about in the video as in the knowledge graph, basically, that are associated with a particular video or a playlist or a channel, and that are relevant for that playlist or video or channel. And in the API, we're surfacing those topic IDs, which are not YouTube API specific. It's actually a fine example of integrating the YouTube API with other APIs that are not YouTube specific. And we give you a way to both discover content by searching by particular topics, YouTube content that match the topic, and the other way around, given a video, what are the topics that this video is related to. The way that looks into the API response is that we have a part that is particular for topics called topic details that lists all the topic IDs that we think this content, this YouTube content, is associated with. From there, you can either take a topic ID and resolve it against the free-based API and understand what that topic is about and what is the other information in knowledge graph we have about that topic. Or you can search for more content related to that topic. That's a YouTube API call that you can make to search for more YouTube content matching that topic. To read more about the free-based API in particular, you can use the link on the slide. Basically, it's a wiki on freebase.com. And it explains what topics are in particular and how they're identified and how do you retrieve metadata about the topics and how do you find more content about them. Talking about YouTube API in particular, this is one of the examples. So if I was looking at the video ID there, and by the way, all the video IDs are used here are kind of like talks that are interesting that you might want to check out. So it's like I didn't choose random video IDs, I just chose something that might send you on the path of finding even more about either YouTube or Freebase or YouTube API. And I'm asking for the topic details of that video ID. And I'm getting back a Freebase topic ID that looks like that. So /n and then / and then the ID. In order to load information about that topic, by just saying the YouTube API response, I don't really know what a topic is, right? I just have this ID, so I don't really know the name of the title of the topic. What is it about? In order to resolve that, we're going to use right now actually the Freebase API, which is also a JSON API. that you can use from this address, basically from Google APIs.com/freebase as well. And I just passed in the topic ID I got. And the filter on this particular API restricts the data you return about that topic. So the topic that video is associated with is API. And it was created by that particular user at that time, and it has that title in English. And there is a lot more if I were to either include more in the filter or just take the filter out. Actually, I can just try that and show you that it's a lot of rich information in the response of the Freebase API. So you get alias topics, you get articles you can read on Wikipedia about APIs. You also are going to see some thumbnails, pictures, video talks about APIs and so on. It's all embedded in the knowledge graph if you want. So you can take any YouTube resource, find the topics associated, go to the Freebase API, find what a topic is about, and find content that is not even YouTube related, Wikipedia, anything else, and pull all that data in and show it in your app, basically. Which should be better than video tags. And then, assuming we have resolved that and we figure out what the topic is about and maybe other content that is not YouTube specific about that topic, we might want to search more videos or more channels that have that topic as well or share that topic. The way to do that is in the search API, just pass on a topic ID as a parameter, and you can specify extra search keywords or not, and that's going to return you even more YouTube content that is associated with that topic. And we have a cool sample client application that I can show you right now. And this is using the search. It's a very simple UI. We didn't want to do too much, but we just want to show you the API call and how it will look like. So for instance, I'm going to search for the API topic that we just had before. This is textual search in topics, so it's going to just match topics right now. And related to API, it has a very good suggestion and a very strong suggestion, API application programming interface. That's the one I actually meant, but there are actually other topics that are related to APIs and that are showing here. I can pick that one, which just means picking the ID that you saw before. And as a result of that, firing a search with the YouTube API, I get channels about the API, about APIs. I get playlists about APIs. So there is an AdWords playlist, there is an about API-G and so on. And I get videos about APIs that I can all search through universal search. How to design a good API and so on.
So is that prioritized through relevancy?
The client application here is actually doing the splitting and shows like channels versus plays versus videos. But normally if you just take the response from the API server, it's going to be relevancy and they're going to all intermingle. Or you can restrict to just videos or just channels or just playlists.
So in this client sample, the filter is the same text box API, Google.
Yeah, I can.
So is that the order of relevancy? The API is the most relevant, and then Google is probably second.
You mean on so the question is if API is most relevant, you mean amongst topics?
Yeah, if I say API,
like here.
Space, Google, space.
So I'm not sure if API Google is going to match a particular API Google topic, but it actually matches topics that has both. And you can try this app out, and you can see the source code of the app as well. It's also linked on the slides. So this is my last slide. So thanks for bearing and being with me still. So you have a bunch of links here that you can follow and read more about version 3. Try it out, register as a developer, and try the sample client application. So you have the documentation. The documentation has a tool that lets you try different API calls directly from the documentation page. So you can both read what this call does and what are all the parameters it takes and what each parameter means, and also try it in the same time on the web interface. The client libraries are linked there, and we have like 9, 10 client libraries that we support. The API Explorer lets you fire API requests on a web interface as well, without having to go through developer registration. You can just try it out on the web interface directly. The developer registration and console is a great tool to monitor your particular client application API traffic, and to register for using your for either just YouTube API or other APIs that you want to use in your application, Google APIs, I should say. There is also technical support, and we have a team of DevRel and people that even us engineers sometimes go on the forums and answer questions that third-party developers ask us. And that's on Stack Overflow, and there is a YouTube API tag for it you can use. The API itself, it's served from googleapis.com/YouTube/v3. The discovery document that I talked to you about, where you can read the schema, both human readable and machine readable, and the client applications.
So, okay.
Thank you very much.